This is a lesson, it's section 2.5 and it's continuation of the study of functions, but it focuses on something called transformations. Now, in order to talk about transformations, it's probably a good idea to take a look at a function library. We may have talked about these in the past, but we're going to review them. The first one is y equals, let's say, x squared. This is the squaring function. Even though I've written it as y equals, it could be written as f of x. It's a squaring function, and the shape, I'm going to call it the U shape, even though specifically that is called a parabola. Another one is y equals x cubed. This is a cubing function, and it looks sort of like a wiggle. Let me redraw that. So it is increasing over its entire domain, but it does kind of a curvature change someplace, and I call it the wiggle. We have y equals absolute value of x, which could be written as absolute value bars x, and so this is absolute value, and its shape is a V, and y equals the square root of x, square root, and this shape is kind of a branch. All right, so these may be helpful and as we talk about transformations. Now, although I've given you a kind of a short library here, what we're going to discuss, which is transformations, is true about any function. So the lesson actually starts with some that do not come from the library. Let's take a look at this little bit of information. Suppose you have a function y is equal to some function of x. Now it can be one of these, it could be anything. If it is a function of x, if you add k outside of whatever the function is, say it's x squared plus 2, it will shift up k units. If you have the function and you subtract a constant, like y equals x squared minus 3, it will shift the function down 3 units. If instead you add a k or subtract a k inside before the function takes hold of it, you will shift it left or right, and it goes the opposite direction of what the sign might indicate to you. If you multiply a -1, and all you would see would be the negative sign, but if you do a negative on the outside, it causes the graph to reflect about the x-axis. So it is an up-down reflection. If instead you change the sign of x before the function has a chance to act on it, then it reflects about the y-axis, and I'm going to say that that is a left-right reflection. If you multiply the function by a value greater than 1, then it gets a vertical stretch. It gets taller faster. If instead you multiply it by a number that is between 0 and 1, that means it's a fraction, then you get a vertical shrink and it does not rise as quickly. So let's take that information and take a look at your problems. Most, but not all of these problems will be multiple choice because it is easier than if you had to draw the graphs yourself. I'm going to switch colors. I'm going to switch to red to do these. This graph is a graph of a function. Yes, it passes the vertical line test. It does have a restricted domain and a restricted range. Nevertheless, it is a function. And it says graph g of x, which is f of x plus 4. When you add plus 4 on the outside of the function, it's going to shift up 4. That means that this point is going up 4 units. This point is going up 4 units. This point is going up 4 units. This one is up 4 units. And this one is up 4 units. So it should look like this. I pick the graph in the multiple choice that looks like that, and I believe it will be choice D. What you needed to recognize at the very beginning, that you are adding something to the function outside of the function's definition. And by the way, I don't know what the function's definition is here. It's not x squared, it's not absolute value, what it is. All right, let's look at number 2. We're starting with this same kind of odd function. This time it says subtract 2 from x before the function acts on it. So what this means is we've got a shift 2 units right. Anytime it's inside the function, before the function, like before you square it, before you take its absolute value, before the function acts on it, if it says minus 2, you go the opposite direction, it goes right 2. So this point goes right 2, this point goes right 2, this point goes right 2, this one right 2, this one right 2, and the graph looks like this. All right, so I look around for one that looks like that, and I believe, again, it is choice D. All right, let's take a look at 3. We have the same f function, and it wants to know what is the negative of f. Now, when you put the negative sign on the outside, you reflect about the x-axis. So this point stays the same, but this point, because it is 2 units below the x-axis, it will reflect to be 2 units above. The point on the x-axis stays the same. This point is 2 units above, so it will reflect 2 units, 2 units below. And this one is on the axis, so it does not change. It's as if the x-axis were a mirror and it reflected it. So it looks like we seem to be on a roll for choice D. All right, this particular transformation is actually 2 transformations. It says change the sign on x before you let the function act on it, and then add 3. This will give us a reflection about the y-axis, and this will give us a shift up 3. So I'm going to do the reflection dotted, and then I will do the shift solid. So reflection, it's a side-to-side reflection. So this point moves over here. This point moves 2 units that way. This one stays the same because it's on the y-axis. This one reflects over here, and this one, the black one underneath, reflects over here. So a reflection about the y-axis took this up triangle and put it up over here, and it took this down triangle looking and put it over here. Now I want to shift up 3 units, all of my red. So this point will go up 1, 2, 3. This point will go up 1, 2, 3. This one will go up 3. This one will go up 3. Oh, whoops, sorry. This one will go up 3. And this one will go up 3. It takes the dotted graph and it shifts every point on it up 3 units. All right, so the dotted graph is where I reflected it. This reflected over here, this reflected over here, and then I pushed it all up 3 units. And it appears to be right here. But I like to physically draw the reflections and the shifts. Let's look at number 5. This one, we're going to have what's called a stretch. And it's going to be a stretch by a factor of 3. You see the 3 on the outside. In the notes, that's A. Every one of the y values is going to be multiplied by 3. So 0 multiplied by 3 is still 0. -2 multiplied by 3 is -6. So that's 2, 3, 4, 5, 6. 0 multiplied by 3 is still 0. 2 multiplied by 3 is 6. So this will go, that's 2, 3, 4, 5, 6. And this one is still 0. So every y coordinate, because you're multiplying f of x is another name for y. Every one of the y's is getting multiplied by 3. It's a little hard to describe, but what it's done is it has stretched it out. And let's see, I know that it is not this one. Whoops, didn't mean to circle it. All right, I know it is not this one. Now this is only going up to 6. This one is going up too high and going down too high. This one is going up to 6 and down to 6. This looks like it may be my choice, but let's take a look at this one. Oh, I see a difference. This is only going out to 6 and this is only going out to 6, but can you see how this has stretched this way also? All right, I'm sorry. Something happened with my technology. Both of the graphs, A and D, show a vertical stretch by a factor of 3, but A also shows a horizontal stretch, where instead of only going out to 6, it's going out to, looks like maybe about 8 or 9. So it's not this one, so my choice is D. All right, now we're going to leave that funny graph and we're going to look for problems numbers 6 and 7. I'm going to actually do these in my math lab on the video because you need, well, not 7, it looks like maybe just 6. Number 6, I'm going to branch off to my math lab. So I won't be doing exactly this problem, but I will be doing one like it. All right, off camera I have logged in to MyMathLab and gone to a similar but different problem number 6. Now right over here you can see it's rather small, but you can see h of x is equal to x minus 4 quantity squared plus 2. Now it is a transformation of f of x is equal to x squared. What did we do? There is a subtracted 4 inside before the squaring. That actually means it's going to shift right 4. There is a positive 2 outside the function, outside of the squaring, and that means it's going to go up 2. So let's see how to do this in MyMathLab. This is a squaring function, so it is the U shape. The basic x squared tool has its bottom point here, and it has drawn it perfectly. All right, now look at this small thing over here. We do not have any stretches or shrinks, but we do have vertical shift and horizontal shift. Let me get access to a keyboard. All right, vertical shift. The vertical shift is designated by the plus 2. So I will put 2. The horizontal shift is designated by this negative 4. So I will put in, and by the way, you see it went up 2 as soon as I hit enter. Let's do negative 4. That should push it to the right. And it did not. So even though we see a minus 4, MyMathLab says, oh, okay, so which way do you want to go? And you tell it four. And I'm glad I'm showing this because I just implied it was wrong. Okay, so I know that minus 4 means shift it 4 units in the positive direction, which is to the right, and a plus 2 means shift it up. This should be our graph. I will save it, and I will check it, and we are correct. So enter the number with the sign that indicates the direction you want it to go. All right, so now I am back, and so with this one you would hit the squaring tool, and when you click over here it would draw a graph that looked like that. But as far as vertical shift, you know that it will go down, so you will put in minus 4. For a horizontal shift, because it says plus, it will go to the left, and you have to put in minus 5, so that it will go down 4 and left 5, and it will look something like that. All right, the next one's going to be multiple choice. Using the graphing tool is a little bit of a struggle. This one says use the transformations on this. Hopefully everybody remembers that this is our branch. When you add 3 on the outside, it's going to shift up 3. So I'm looking for a graph that looks a little bit like a branch, and yet it has shifted up 3 units, and it's this one. You can see that everything has gone up 3 instead of starting at the origin. On this one, it's still x squared, so it's still going to be a branch. This says it will shift up 2. So I'm looking for a graph that has shifted up 2, and I believe it will be choice C. Number 9. It is still a square root function, so it is still the branch, and they've drawn this original picture. When they put -4 on the inside, it's going to shift right 4. You have to remember that when they put it on the inside, it's going to go the opposite direction of what that sign usually says. So that's going to be choice C. And these are in scales of 2. So that's 2, then 4. Okay. All right, this one has a couple of transformations, and you want to go inside out. Inside, it says +6. So that's going to go left 6. After I go left 6, then I'm going to reflect about the x-axis, which is an up-down shift. All right, so I'm thinking about it. I think I'm going to draw a little sketch over here. It's going to go left 6. So instead of starting looking like this, it's going to go 1, 2, 3, 4, 5, 6. So it's going to look like this. But then it's going to reflect about the x-axis. So everything that's up is going to come down. So I'm going to say that it looks like this, and I'm going to try to make it a little bolder. Nevertheless, it is still on the x-axis, and this one has shifted up, this one has shifted right, this one has shifted down. All of them are reflections about the x-axis, but this is the only one that has the correct horizontal shift. Look at 11. Lots of times I like to draw it myself. All right, still a square root function. This -4 means it will shift right 4. This +5 on the outside says it will go up 5. So I'm looking for a branch that will do two things. It will go up 1, 2, 3, 4, 5. It will go right 1, 2, 3, 4. So right 4, up 5. This point is the same as this point, and then it does its branch. So I believe that is choice B. Right. This one asks us a few things. It says, begin by graphing the absolute value function. So in my mind, or on a piece of paper, I know that the absolute value function, is this V shape. When it says +5, I know that that's going to shift up 5, and I know it's up because it's outside of the absolute value. So when I say shift, that is another way of saying a translation. Translation is a shift. So we have a vertical translation, which is a vertical shift, and it is up 5, so I believe it is choice C. Number 13, still absolute value, so I know that it is starting like this, and we have a -5, but it's inside, so it's going to shift, or remember that means translate right 5. So that is a horizontal translation, and I'm looking for the graph that shows the absolute value V shifting to the right 5, and I believe it is choice D. All right, this next one has quite a few changes. It is an absolute value. All right, let's start on the inside. Inside, this will mean a translation horizontal, so it is a horizontal shift or translation left 2. All right, so horizontal, this time they called it a shift. So we need to be able to say shift or translation. We also have this. The 2 part of it means that it's going to be a vertical stretch or shrink. But the negative part means that it's going to be reflected about the x-axis. So just the negative sign says reflection, and it's outside the function, so it's about the x-axis. The 2 says it's going to be, in this case, a stretch, and then -3 is a vertical shift. So we have all of those things going on. So I'm going to start out just looking at the shifts. This one says left 2, and this says down 3. So left 2, down 3. It's going to flip over because of the reflection. Well, these are all reflected. But the only one that has moved left 2 and down 3, and the down 3 is after it has reflected and shift and stretched, is going to be this one. You can see it moved left and down. Now it moved, it used to be up, and then it flipped down. All right, let me say that one more time to make sure, because things happen in a particular order. So the graph, first it looks like this, and I'm going to have a series of dotted graphs. Now it's going to go left 2. So now it's over here. Then it's going to reflect down, but it will actually be steeper because of the negative, not just negative, but -2, and then it's going to shift down 3. So this big mess kind of explains better why it looks like this. All right, let's try another problem. All right, I'm going to go to my math lab because this one actually asks you to graph. My problem will not be the same as this problem, but it will be very similar. All right, I've logged into my math lab, and I asked it to enlarge the graph. When it did, it also gave me the tools over here. Let's talk about it first. Because it has a minus, this is the cubing function, which is the wiggle. And you can see the wiggle right over here. All right, inside it has -6, which is going to be a horizontal shift right 6. This is going to be up 6. But let's start with our graph. All right, it starts right there, and it wants to know about, okay, vertical shift. Oh, I don't know if I can even count. Oops, that's 8. Oh, that is 6. I can see it right there. And then I need to go right 6. This will be easier if you can enlarge this on your own screen. And I believe that's 6 to the right. So it went up 6 and it went right 6. So I think that's it. Save it. check it, and we were correct. All right, back to our problem set. 16. Oh, okay. I guess I will go back to my math lab for this one because it is actually graphing something. So back here, go to my next question. All right. Now, this one has a coefficient of 1/2, and I believe that yours had a coefficient of 4. So we're going to have to notice that. You have to look at your problem and see what you get. So I click to enlarge it. I'm going to start with the wiggle tool. There it is. Now, inside I have a horizontal shift of left 4. So this time, every time they do this, I have to hook my keyboard back up. So you might hear some things. Okay, I'll do it in whatever order I see it. Vertical shift. Looking right here, I see a vertical shift of 3. I'll put in +3 because I want it to shift up 3. And if I hit enter, it should... Oh, I didn't read correctly. I'm going to back that up. This is a vertical stretch or shrink. So in here, I'm sorry, I will put 1 divided by 2. I could have put 0.5. Okay, what it did was it squished it down a little bit. That was a shrink because that was a fraction. I don't have any horizontal stretching or shrinking. Vertical shift. The shift vertically is up 3. The shift horizontally is left 4, so I will put in -4. I put the opposite, and there is no reflection, so save it and check it. All right, so you've just got to read those little teeny words, and I did not do that. So let's go back now. So we did that one, and I believe that is our last question on transformations. So with transformations, I'm going all the way to the top. Here we go. And I started with a library of functions, and we saw maybe all of those. These two were called reflections. All of these were some kind of a translation. Sorry about the messiness. It's the way I'm having to hold my pen right now. And then these are stretches and shrinks. So refer to this video if you need to, and I hope you have fun working on transformations.